Hello everybody, my name is Walter. Today I want to present to you a new feature in MaxQuant and Perseus where you can annotate the raw data with all kinds of metadata. And the feature is called export SDRF file in MaxQuant. So the general challenge in proteomics is that we have a data set where the people that handled the data know much about, but once it's published, not everything is known, and sometimes some information is missing. And therefore, the link between dataset generation and the provided data files is often missing. And how is that already solved in the field? It's solved by using SDRF, which stands for Sample and Data Relationship Format. And there you have all kinds of different categories to annotate the data. And the data can be annotated on characteristics such as what organism, what disease, and for example, also phenotype. Then comments on the technical sides, what SC name it was, for example, in this example 1, and 2. Then if you use fractions, what fraction it is from that run. And if the labeling method is label free, for example, you can just tell that it's label free, but also all kind of different labeling methods can be summarized there. And as a third category is, for example, the factor value phenotype, which means then basically in this disease, I have the chronic control and then the tumor itself. To now show how we do it in MaxQuant, I will open MaxQuant. And for that, you just press, like you would normally do, load folder or load it by drag and drop. And I've prepared here a folder with those raw files, which are TMT runs with 24 fractions. Let's just call the experiment now experiment 1 in this example, but in the output later it will be called different. And then we have fractions, so please don't press no fractions, set fractions. We have 24 fractions. And now the raw data has some information already. And if you now go to group-specific parameters, you need to set it to reporter MS2. And this experiment was a 10-plex TMT experiment. And that's already then saved now. And the last step to prepare the data is to add the FASTA files. We have here Homo sapiens FASTA files. And now in a normal MaxQuant run, you could just press start now and it would do the analysis. And what's new now is that you can go to the metadata tab, which is right next to global parameters. And if you press refresh, MaxQuant will automatically take care of it. So let's do that. And here you go. So you have the experiment just as you called it before and the raw files. And we picked that exact experiment type because we have a combination of fractions and reporter MS2. So in this case, TMT labeling. And here you can see I have all 24 fractions in the fractions row or cell. And also it's split then into each of the 10-plex. So as you can see, I've in this cell 24 fractions, and then in the channel column, I have all the 10 plexes. And what else is automatically filled is once you've added the FASTA files, also the organism, it can be also many organisms, everything will be in that column. And the rest is empty for now, or in the case of replicates, because it's required later for the upload to have at least a number there. We filled it in with one if you don't have added anything. And the rest is empty. You can leave that actually empty. If it's left empty, we will fill it in with not available. And let's Anyway, select now a column and fill it out. For example, we could say here in group, I want to select that rows. And if you go to edit column, that is here, sorry. Then you type in the column you want to edit. It's also case insensitive. And then you just say the group is 1, and it will change every row in the column you wanted, basically. And now the only remaining step would be to write SDRF. And then once it's successful, it will tell you where it is written. So for that, it's in the combined folder, a folder called SDRF, and there you will find the SDRF TSV. But also, if you run it from scratch now, so if you press start, it will at first, if you forgot to write SDRF or do anything here, it will also do the same as I did now, but without editing the group column. And once the last step is finished, which is writing tables, it will also copy that SDF file to the TXT folder. You can also write and read a template, which can be beneficial for standard experiments, for example. So if I write the template now, it will, based on what you have filled in, will make a table that you can edit, for example, in Excel, and then you can read that in later. And that is everything you need to know in MaxQuant. The output table we can also load in now to Perseus. For that, let's open Perseus. In Perseus, it's way easier. You only need to load your experiment, basically. So this is of the same data set, the output protein group table. And in TMT, you have for example, you can use now the report intensity. So load all the columns report intensity. And now you can directly annotate each of the columns with the data created in SDF, so the metadata. You just go there to annotation rows, read SDF, and then you should just select the SDF file, which is in this case the SDF DSV. And if you press OK, you can see how much information can be actually automatically extracted. So, for example, it's often required for SDF to know what kind of technology type was used. So, in this case, proteomic profiling by mass spectrometry. And then you see also the fraction identifier, what MaxQuant version was used, what type of data acquisition, and so on. As you can see here, you have quite much redundant information in all the different columns. Therefore, we have also an option to skip repetitive information. If you want to redo that, you can also press here to that pencil. And then it will show again the things you did. And there's the option skip repetitive properties. And if you check that and press calculate, it will then only show what's really non-repetitive. And in this case, it's actually only the TMT region. And with all that information, you can then later do also automatically have your annotations. And this is really important also for users themselves. If you want to do now statistical analysis, those annotation rows are automatically saved. So it's not only beneficial for the community to have information about all your raw files, but also for every user themselves to directly be able to edit the information. So as you can see here, you only have the different TMT regions that are differing between the samples. But of course, in a real life experiment, you would then have different disease, healthy control, whatever, different gender, different age. All that can be here. And if you skip repetitive properties, you will only see what's important, basically. Thank you very much.